Okay, so this is 8.7b as in Bravo, and this is the last thing we're doing with circles. We're converting the equation of a circle to standard form. So what we're going to do is we're going to take our equation, okay, and we're going to make that in standard form, and it's also asking us to locate its center and the radius. So we're going to look for both the center and the radius as well. So first thing we're going to do is we're going to get the x's together. Make sure we have the signs that follow along with it. And we're going to put our constant, our 3, over here. Okay, so all we have are variables over there. Alright, so now, if you remember right, our formula looks like this. And this is what we're going to try to get it to look like. Whoops. Alright, let's erase this mess, try to get it fixed. Okay, that's an h, that's squared, and that equals r squared. So we're going to get it in that form right there. Alright, so in order to do that, we've got to have two quantities squared. Okay, so in order to do that, we're going to do a completing the square thing. So what we're going to do is we're going to take half of that and square it. Half of 4 is 2. We're going to square it and get 4. And we'll parenthesize that. Then we're going to take half of 6, square it, and put parentheses around there. And that equals 3. But because I added 4 here, I have to add 4 to the other side. I can't just add a number to one side and not do it to both. I added a 9 here. I have to add a 9 here. Okay, so what I've got here is a 16. So I'm going to replace that if I can, which maybe I can't. I'm just going to have to do that. That equals 16 there. Alright, so that factored is going to be x plus 2, the quantity squared. Because if you remember, when you complete the square, you take the square root of the first term, square root of the second term, take that sign and put it there. We'll do the same thing here. Square root of the first term, square root of the second term, and that sign goes right there. And that equals 16. So there's our equation. Now, we also were asked to find the center and the radius. Okay, so the center is going to be whatever makes the parentheses here 0 and the parentheses here 0, which in other words means the opposite signs here. So my center of the circle is going to be -2, 3. And my radius is going to be, because the radius, this is r squared, right? 16 is r squared. So to get rid of that radical, or that exponent, we take the square root of both sides, so r equals 4. That ends up being my radius. Okay, so that is it as far as circles are concerned. And we're going to jump in here and talk about parabolas for just a minute. Okay, so we did some things with parabolas earlier. And if you remember right, a parabola has as its function y equals a squared, or ax squared plus bx plus c, where a is not equal to 0, because if it is, it gets rid of that whole thing and makes it into a linear equation. Okay, so pictures I have here on the right are two different types of parabolas we're going to look at. You've seen these. These are called vertical parabolas, and these are called horizontal parabolas, okay, because its axis is vertical here and its axis is horizontal here. Okay, so we have a couple things we want to talk about with these, and then we'll move on. A parabola is a set of all points in a plane that are equidistant from a fixed point called the focus. Okay, if you notice, every point along here is going to be the same distance from this point right there as it is from this point right here. So for example, this point here, if we go from here to here, this length will be the exact same length from here to here, okay, when this is perpendicular. So if I had a point up here or anywhere along here and I measured from here to here, this distance here is going to be the same as the distance from here to here. This is called the directrix right here. And notice the distance from here to here is the same as the distance from here to here. So the vertex is halfway between the directrix and the focus. So if we're right here, we went up P to get here, and we went down P to get here. So down P means we went in a negative direction. So we went down basically Y. Okay, anything below the x-axis is negative. Okay. So this point right here is x, which is this point right here, xy, went over x and up y. That's going to be, to get here, we went over x, the same distance, and down P. So this point here, again, is on the directrix. Okay, this drawing right here is the exact same. We just flipped it sideways and made our axis horizontal here instead of vertical. All right, so there are two different equations we're going to look at. So when you're talking about an equation for the top one with a vertical axis, we have as a formula x squared equals 4 times the length of P times y. And again, the length of P is this distance from here to here. We're going to multiply it by 4 and then multiply it by y. And that will equal x squared. The horizontal one then is y squared equals 4px. Okay, so that is the formula for that. And a lot of times they will write this as x equals 1/4 y squared. Okay, so if you're looking for the x, you're going to take 1/4 y squared. All I did was took this and solved it for x and got 1/4 y squared for that. The vertical axis could also be solved for y and be, come on, 1/4px squared. Okay, so if we just wanted to solve for y and x, those would be the formulas we use. If we're looking for x squared and y squared, which I'm not going to really do very often, you're going to use these two. So these are going to be the ones that are going to end up being the most handy. So let's look at example 5. They want us to write the equation of a parabola whose vertex is at -1, 3, and focus is at -3, 3. Okay, so the axis contains the vertex -1, 3, and the focus -3, 3, so it is horizontal. How do you know it's horizontal? Because your y values are the same. The y values are the same, it's going to be a horizontal. Because if my vertex is at -1, 3, let's say that's -1, 3, and my focus is at -3, 3, that means I came up 3 to get to the vertex, I came up 3 to get to the focus. And both the focus and the vertex will always be on the axis. And if it's on the axis, then this axis is horizontal. All right, so how do I do this? The distance from the vertex to the focus. Okay, so the vertex to the focus point here. I'm looking for P here because remember the formula includes P, so I have to find that. So again, the distance from the vertex to the focus is going to be -3 minus -1. So that's going to be -3 plus 1 is -2. Okay, so my P is -2. Now, how did I get this? Well, because this is a horizontal, like this, I'm interested in the distance of the x value from the focus to the vertex. So I'm interested in the x values here. So I take -3 minus -1. Okay, so that's going to be the distance between the vertex and the focus on a horizontal. If I was this way, I take the distance between the y values, but notice the distance between those is 0, so obviously that's not going to work. The distance is never 0, so that's how I know it's going to be a horizontal. So I take the difference between x's, so I find P is -2. So the standard form of the equation then is going to be y minus 3 squared equals 4 times -2 times x minus -1, okay, which equals y minus 3 quantity squared equals -8 times x plus 1. Okay, so where does all this come from? It comes from the formula in green, the standard equation of a parabola, where we have, let me do this in blue, y squared equals 4px. Okay, here's my y squared. Okay, I don't know what my y is, I just know what my y is. I just know that the difference of these two would give it to me, so I'm going to square that, equals 4, that's what this is. P we found out to be -2, and x would be, again, x minus -1. Okay, so we've got our vertex here, and we're going to put my y point here and my x point here, and then that's going to change to plus, do my work, and then put it in that form, and I get that for an answer. Okay, so this will be the last example. This is example 6, and they want us to graph this equation. All right, so there's a y squared term, but there is not an x squared term. So we know the graph of the parabola opens to the right or the left. So it's a horizontal one because of this y squared right there, and we don't have an x squared. All right, so we have our standard form of y minus k squared equals 4p times x minus h. Now that's this formula that I should have threw up there on example 5, because that's the format that the equation should be in. All right, so let's get our y's together. And we don't have any x squared or anything, so we don't even want anything over there. So we're going to take everything else and put it on the other side. Okay, so we're just going to complete the square on this one. Half of 6 is 3, squared is 9. So we're going to add 9 to both sides. So -5 plus 9. And -5 plus 9 is actually a plus 4. So let's go ahead and put that up there like that. And then we can do this And that equals, we're going to factor out a -4, leaving me with an x minus 1. So, wow, hunky-dory, it just flipped over and turned into that format right there without really having to do anything. So the vertex then is these 2 points, or these points, or coordinates for these points, 1, 3, because there's my x and there's my y value, and there we go. That gives us a horizontal parabola that looks like this, but it's going to go this way instead, and that's it for 8.7.